Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 9A assignment. First one we're going to take a look at here is number 1. On separate axes, plot these points. So for 1A, it's 5, 0, 0. This is going to, first one's X, second one's the Y, third one is the Z. X is forward, Y is to the left and right, Z is up and down, and X is front and back. So that's positive 5, so that means we're going to go forward 1, 2, 3, 4, 5. There's 5. And it doesn't go left or right, and it doesn't go up or down. So there is our point 5, 0, 0. Okay? For F, we've got 0, 4, 3. So X is the 0, so it doesn't go anywhere. It doesn't go front or back, but it does go 4 to the right. 1, 2, 3, 4. And then it's going to go negative 3, so it means it's going to go down 3 on this. So this is kind of the weird part. So now you can literally just go down 1, 2, 3, and there's our point right there. Okay, kind of weird to do 3D graphing, but you'll get the hang of it. Next one, number 2, for each pair of points, find the distance A to B. So we're going to find the distance between these two things. Okay, not that you have to, but it might be easier for you to see what we're doing here by graphing this thing here first. So X is 1, that's forward 1, Y is negative 1, so that's left 1, and then it's up 1, 2. So you kind of gotta rough it 1, 2 on the vertical part. So that is 1, negative 1, 2, and then 5, negative 3, 0, 5, negative 2, 3, and 0. There's no up or down, so it ends up being that. So it's going to be the distance between these 2 points here. Okay, so maybe to make this a little bit easier, it might be nice to drop this straight down, make it like a little right triangle type thing, and away we go. So I find the easiest way to do that is, let's go back and let's write this point in here first. 5, negative 3, 0 is that point, and then I feel like the easiest way to do that is to do 1, negative 1, and then it went up 2. So I know that it's going to go right straight down to this point here, because then it just went straight up 2 points for that 2 there. So I'm just going to draw this here, and now you can at least kind of get an idea of what that length is. Okay, again, you do not have to do that, it's just to kind of help you see what's going on. So really all we need to do is to use our distance formula, and the distance formula is square root, and we are doing, there we go, we've got x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. So it's basically just subtracting, take the square root of all of the distances between each of the x, y's, and z's squared. Okay, so on this here, square root, if we do our 2 x's, so let's see, the first point here was this one, so this is, we'll call that 1, and that's point 2. So officially, if we're going to do it exactly like the formula says, we would do 5 minus 1 squared plus negative 3 minus negative 1, and then we would do 0 minus 2 squared, and that's going to be the distance between these 2 points in 3D space, right? So we're going to take the square root. 5 minus 1 is 4 squared. That turns into a plus, so negative 3 plus 1 is negative 2 squared, and then another negative 2 squared. So I would suggest doing this in your head, not in a calculator, because a lot of people will forget to put the parentheses around, and this will you'll end up getting something goofy. So anyway, we know 4 squared is 16, negative 2 squared is 4, negative 2 squared is 4. So this distance is going to be 16 plus 4 is 24, which we could probably just leave it like that. or we can simplify it also. So square root of 24 is square root 4 times square root 6, right? So that is going to be square root of 4 is 2 root 6. I'm probably feeling pretty good if you got square root of 24, but 2 root 6 is a little bit better answer. And then I guess this would be units, right? Okay. So there's our distance, and then the midpoint, we just use the midpoint formula for this, which is just like the midpoint formula for 2 points. That's got one extra piece, right? So we'll do x1 plus x2 over 2. This is midpoint. And then y1 plus y2 over 2. And z1 plus z2 all over 2. So in this case, we get our x's. We will do 5 plus 1 over 2, negative 3 plus negative 1 over 2, and 0 plus 2 over 2. All right, so that gives us 6 halves, negative 4 halves, and 2 halves, which is simply 3, negative 2, and 1 would be our midpoint for that. All right, moving on to a different one here. Let's see, I'm going to get rid of that. Suppose A is 3, 1, negative 2, B is negative 6, 7, 13, and C is 5, 9, negative 4. Show that triangle ABC is right angled. Okay, so in order to do that, we're probably going to want to find the distances between all these points, and then once we do that, we can see if we can get an a squared plus b squared equals c squared going on. Okay, so here is our distance formula again. So let's do distance from A to B, and then we'll do B to C, and then we'll do C back to A. So we're going to do distance formula 3 different times, then do a squared plus b squared equals c squared, see if it works. Okay, so we're going to go A to B. Let's just, I'm just going to start with this x here. So we'll do 3, because it doesn't matter which one you subtract from which, because you end up squaring it, which just will take away the negative, or if it's a negative, it'll get rid of that negative sign. So anyway, 3 minus negative 6 squared, and then 1 minus 7 squared, and negative 2 minus 13 squared. Okay, so that is 9 squared plus negative 6 squared plus negative 15 squared, right? Okay, so I put that in, and again, I like to do these squares in my head to make sure I don't mess up a negative here. So the 9 squared is 81, negative 6 squared is 36, and negative 15 squared is 225. And we take the square root of that, and we get 18.49, right? And let's see, let's just go with that for now. 8ab equals 18.49. It'd probably be nicer to have this in root form, but we'll go with this for now. Okay, and then now we're going to do, let's say, BC is going to be, so from B to C, we'll do negative 6 minus 5 squared, 7 minus 9 squared, and these are added together, and 13 minus negative 4 squared. Right? So BC is going to be negative 11 squared plus negative 2 squared plus 17 squared. Alright, so we can get our calculator back out, do that one again. Square root of, I'm going to do this without the sign on it, because I know it's going to go, I know what the sign's going to just be, it's going to turn to all positive once you square everything, plus 2 squared plus 17 squared, because I don't have 17 squared memorized, but anyway, 20.347 we'll call it. Let's do 20.35, I guess. So that's what we did with the other one. And then let's do, what do we got left? We got A to C. So AC, A is 3 minus 5 squared plus 1 minus 9 squared, and -2 minus -4 squared. So AC is going to equal 3 minus 5, that's -2 squared, and 1 minus 9 is -8 squared, and then -2 plus 4 is 2 squared. So we should be able to put that all into our calculator, and away we go. So we square root 2 squared plus 8 squared plus 2 squared, and we get 8.49, we'll call it. Alright, so we know that if we're going to try to make this into, if it's asking, it says show that it's right angled. So if we're making a right triangle here, we know that our hypotenuse here is always going to be the longest side. So that's going to have to be 20.35 would be this. And then these other two sides here, let's call it 8.49 and 18.49. If that's a right angle, a squared plus b squared should equal c squared. So let's check it out. 8.49 squared plus 18.49 squared should equal 20.35 squared. And then let's check that out and see if that works. 8.49 squared, and if it works, it should be pretty close. We did round these off, so it's not probably going to be exact, but it should be pretty close. So this gives us 90. That's not right. Oh, I forgot to square this one. Squared. There we go. 413.96. Is that pretty darn close to whatever 20.35 squared is? Let's check. 20.35 squared gives us 414.1. Let's see, 0.12 if we're going to the nearest hundredth like we've been with the rest. So that's pretty darn close. So I'm feeling pretty good that that is accurate. Again, just because we rounded those off, it's going to be off a little bit. Okay? Okay, that's all we have for the 9A problems. If you have any further questions on any of this assignment, please feel free to ask. Thanks.